Hey, it's Bree. I'm going to show you how to use the Confocal microscope. So basically, what I did first is I made the slide. So this is the slide I made. It sets up so that you know which side is up. I took some worms off of the plate with my little worm picker, put a drop of distilled water onto the slide, and took the worm picker and shook it off in there a little bit, and then put a cover slip on top. This is an inverted microscope, so it needs to go cover slip side down. I already have this in focus because I've been doing some imaging already, but if you don't have it in focus yet, I recommend doing like a known slide from in here, one of these things, so that you can get it in the right plane, because C. elegans, as you know, is see-through, and it's going to be really hard to focus something see-through when you don't know exactly where it is. Anyway, so I booted up the whole microscope. The software is open, and then I am going to figure out where it is just using like the regular light path and not the lasers. So give me just 1 second, I'll do that. Okay, so I have it in here. I'm gonna flip it so that you can see. We've got our little worm in there. See really well his whole intestinal tube. That's pretty cool. About midway through on the left side, that is the vulva, and then I believe the rectum is all the way at the end. I'm not entirely sure. But yeah, so now that we have him in our sights, we will go ahead and switch to the laser part instead of just the lights. So give me a second and I'll show you how to do that. I turned off the lights in the room so that we would get as little background light in to the detectors as possible. So basically what we do now is we flip from the diascopic to our end spark. It's going to take a second to get there. The experiment that I have for this specific strain, this strain has the RFP and the GFP fluorescent proteins. So I have created this experiment, which is really easy to do. You just click add, and then you can go based on dyes or based on, you know, your specific lasers. I'm going to go based on dyes, and then you can search for, say, green fluorescent protein, and you've got a bunch of them here, but we're just going to go with the basic one, or red fluorescent protein. There we go. There are a lot of specific ones for which specific wavelength, but we're just going with the regular one that worked well just for me. So I made that myself, and I have titled it C. elegans ? Because I wasn't sure if that would work or not. When you make them, I added the GFP, the RFP, and then the transmitted detector. That way I would be able to have this image also, just like regular light, transmitted light going through, so you could see what you're looking at also. Anyway, moving on. It is going to take it in 2 channels. I assume the reason is because these are so close together. You can't take them both at the same time. Not sure. We'll be looking into that. The bidirectional is the way you want to go. It's what gets you the best like image per phay. It will auto-populate these. The more you increase your integrating and dwell time, the more you're blasting the subject with lasers. So if you're trying to keep them alive, keep this as low as possible. The settings that I found for RFP and GFP were pretty low, something between like 3 and 6 for each of them. That gets you a pretty good image without like blowing it up like I did yesterday. And then the transmitted detector, keep the gain, you know, around like this 30 to 40 mark. CF mode, always put it in CF mode. Faye said there's absolutely no reason for it to be in SR mode. This is just some relic of previous what's it called? This previous program. Anyway, you also want to make sure that you have nothing in the first turret, otherwise you're not going to get an image. I can't remember what these do off the top of my head, but you're not going to get laser image if you have something in here. So keep this empty, keep this empty. This is just which objective you're using. So I've been at the 20x to get this close of an image, which is pretty good. Anything over 20x you're going to need to use oil immersion for. I have not tried that yet. We'll be doing that eventually someday, maybe today. So basically that's about the settings that you want to use here. So then we will go into see what we've got going on. So we're going to click live, and it's going to just scan over and over and over. Right now it's just doing the red because we have red selected. So you see all those places where the red is, which is pretty cool. And this is the red and the transmitted detector together. You want to flip over to green fluorescent protein, flip it over and it'll do the green for you. Very fun. So then we're going to freeze, and we want to capture the image at all these settings. So basically in the live mode, what you're doing is figuring out which settings you want to use and making sure that that works. And then when you're ready, you hit capture, and so then it's going to capture. What you're seeing is nothing here. There's a reason for that. You have to go up here and click auto scale, so that way it scales the lookup tables. It's not changing the data, it's just making it able for your eyes to see. That's how Faye was explaining it. So we've got lots of green, got some red, kind of looks like a snake. That's kind of fun. And you can adjust your own lookup tables down here too. So if you click this button, you can have the lookup tables on and off. And then you can change it yourself. So the farther out they go, the dimmer it gets. The closer together you put these 2 points, the brighter it gets. This isn't changing anything on the sample. This is just changing the image and how it's scaling for your eyes. So nothing about the data is being changed here, just image. I'm going to go ahead and change the lookup tables for the transmitted detector so you can see a little bit better. See how it gets overexposed and underexposed. Nice little happy middle there. And you can see the vulva, the mouth parts, all going through here. So once you're done with that, then you just click File, Save As, and you type in what you want to call it. So I named this one Doug Example. We're going to save that. Now so this shows all the channels. So this is all the channels, just the GFP, just the RFP, and this is just the transmitted detector. You can turn that off, and you can just have all the channels. I don't know why you do that. You can turn it off with this button right here. This button shows the merged, all of them together. You can turn that off if you want to. You can also, when you're going live, you can move around here, move this point to center. So let's see, move this point to center, and then the next time you go live, it moves you here. I feel like you can also there's a lot of other stuff that you can do that I can't remember quite this second. There's this option over here is the autofocus and the auto signals. It gets you pretty, it's not supported in this configuration. Anyway, it gets you pretty close, Faye said, to the optimal settings that you might want, or at least not perfect, but gets you close. So that's pretty much the basics of doing like the mutant strain of C. elegans that we have. If you wanted to do the other slides that we have in here, all you have to do is go in the experiment to, this is what Sally set up when we got started. So Bree's amazing experiment, and these are all the dyes that were used in the fluorescent slide that she gave us. And you can just go in and change up some things. Let's see if it works for this. Pause this. Okay, so this is cool. They all have autofluorescence. All living things have autofluorescence. So I'm assuming Dappy this is the blue, is on the same wavelength as what a C. elegans would all autofluoresce. So that's kind of cool. You also see all this stuff over here. I didn't get to wash the C. elegans as I pulled them off the plate, just for, you know, simplicity's sake, but this is likely all of the bacteria that I picked up when I picked up the worm. And this looks really similar to the green fluorescent protein and the red fluorescent protein. So it'll still work if you click Bree's Amazing Experiment instead of C. elegans ? But you also get this pretty blue stuff, and you get to see the autofluorescence of the bacteria in the background. So that's kind of cool. I paused that one and it went a little bit slower because the integrating time was increased to 2, and that was just based on the settings that it had previously for this Bree's Amazing Experiment as opposed to the C. elegans ? Yeah. I'm a little sick, so my voice is low today, and I'm also kind of like brain fog, so I'm sorry if I'm spacing out a little bit. But anyways, that's taking a quick image on the Confocal. Let me know if you have any questions and we can talk about it. Bye.